Hello, 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 and welcome back to yet again another Fusion Friday with none other than Fusion Phil over here at jitcadcam. I see you guys all out there in the chat. Go ahead, feel free to let me know if I sound terrible or if I'm sounding good. As well, is my video coming through all right? I did have to make quite a few changes this week. Bought a new desk finally. I got one of them fancy sit-stand desks to help with this. Dylan, we see you out there, Dylan. I love it. Every week you are back here. If I ever get shirts or hats or something made, I'm sending them your way. Travis also. Bogdan, you guys are great. You guys come back every week, of course, and always point out things I'm doing wrong, as well help everybody else as you can, and I appreciate that. Deep Thinkers here as well. Awesome, awesome. I appreciate it. Yeah, I mean, hands down, man, we have an Airbnb at our place. You're welcome to come out. We could do some pheasant hunting. Cool, guys. I'm going to give this a few more minutes. I see a few more people rolling in here and there before we kick this off. I have a couple of requests that I'm going to run through. Some simpler things I saw this week in question-wise as well. If you guys know the rules, feel free to ask at any time if there's something in particular you're hoping to see or wanting to see. You could also do that through chat. We are on Discord as well, and there is a support email address down below. You can use at any time to send me a message, and we could actually create a ticket and show that live. Or if you're watching the recorded version of this, you can also use that support email to send me problems you're having, and I'm happy to troubleshoot in any way I can. So let's go ahead and crack this open and see what we have going on. So first and foremost, let's get a part open. I'm going to start with actually kind of an extension. A few weeks ago, we did a Workflow Wednesday talking about chamfers on a part. And lo and behold, one of you reached out and was wondering, on a part like such, there's an extrusion that slides over this. So these chamfers here are basically aesthetic chamfers for the most part. They're not too critical on a dimension. But with that being said, what I'm going to do is, we talked about a lot of ways to do chamfers, and somebody pointed out a way I completely missed, which works perfect. It works so perfect on this workflow, and you'll see why. So what I showed you all is, let's use 2D contour. I'm going to go ahead and grab that spot drill. You guys didn't know, if you didn't model a chamfer, I tend to use 2D contour. Now you're going to notice we have our chamfer here. And normally what I would do is I would pick the lower edge. So I'm going to go ahead and hold my Alt key and grab those two edges. But the problem that's going to occur here, I think you guys are going to see this, is based on that information, we're going to get our path, and what you're going to notice in this case is we're actually coming in with a very weird lead in and then wrapping around. Now, the way this was modeled is this chamfer actually follows the radius or the diameter of this corner, right? So if I was to do, as some of you are probably thinking, a tangential extension, what's going to be funny here is if I actually attempted this earlier and it didn't do what I wanted it to do, and I think you guys are seeing this, right? It is tangential to that last segment, which means it continues straight. So in this case, had we done a tangential extension and tried to achieve something like this, we're actually still leading in and plunging into our part and then moving around this edge. Now, again, this is more of an aesthetic feature based on this model, but the trick to solve this, somebody actually suggested after my chamfers video on Workflow Wednesday, was if you use 2D chamfer, same exact tool, edges to define. In this case, we're going to go with the upper chain, right? So I'm going to grab those two edges. Again, we're going to just give it 100 thou. And if you can't tell already, what's going to happen is we're going to extend off of our part tangentially. But as you can see, I could start out here and then come into that edge and around that edge. Now, the trick here when using 2D chamfer is we actually have to use our tip offset, because this is from that contour, right? So knowing this contour is up here at the top, I'm going to go ahead and hit OK. And what you're going to see is, of course, we're offset 40 down. But what you're seeing is based on the center line of my tool. This tool doesn't have a flat. It is following that chamfer exactly as needed. So what I would have to accommodate for is how far off do I want to offset that tip? And in this case, if I do setting number 2, I need to add at least 140 to that. So if I wanted to go back into that tool path, now I'm going to keep 40, and then I'm going to simply say plus another 140. And what that is going to do is, one, we're going to have to remove that equal sign. Let's go ahead and hold our shift key and hit plus. But that is going to bring our tool further down, but it didn't. Now, does anybody out there know why it didn't? Michael, I see you out there. Hello to you also. I'm going to give you guys a moment to put something in chat because I only think there's like a 5-second delay between me talking and the chat. But why do you think it only moved down a minuscule amount, even though we typed in 0.14? Does anybody know the answer to that? So again, what I'm going to do is I'm going to go ahead and set that back up. It was 040 inch, and then we said plus 0.140. And I'll give you guys a second here. Clearance? No. Good guess, though. Very good guess. Anybody else? We'll give this a few more minutes. I shouldn't say minutes. We'll give it about 20 more seconds if anybody's got the answer out there. What could have happened is I'm going to hit OK, but you guys can see is we're going to go ahead and copy this so I can paste it back in again. But what you're seeing is it's not moving at 140, right? That's pretty clear. Max, Eli, I see you out there. You appreciate all the videos I do. Dude, I appreciate you guys. You guys make this a blast, and you have been fueling my drinking throughout the weekends by buying me all those beers. As well, I guess we now have Super Chat for those of you not in North America. That I appreciate you, man. You make it worthwhile. If you have any questions, go ahead and throw them in the chat. But what is the answer to the problem? Well, the answer to the problem is by default inside of Fusion is the fact that we type this in and it doesn't have a measurement at the end of it. So had we said IN here, Fusion is defaulting to the metric system. Again, don't yell at me, guys. Put it in chat, but don't yell at me. Is by adding IN to the end of that, that has now made that an inch increment. So if you didn't actually have your piece of measurement there, it would actually throw off your part. Now, we could have, at the end of the day, of course, instead of putting our plus 140 at the back, we could put plus 0.140 here, leave the IN. But again, now what you're seeing is yours truly, of course, using a lovely equal sign. And as you can see, again, we're getting another different change because the 0.04 versus the 0.14 IN, what I would do, again, it would have been very easy, guys. I'm just showing you some cool things here. Is had I just typed in 180 IN, we would have got our answer. But we could also do 040 plus 140. And then we could throw this in parentheses, of course, and times it by 1 IN. So again, is what that's going to do is, oh, we got to delete that out of there. That is going to take our dimension of whatever we get and times it by 1 and keep it in inch, again, shifting us down. Again, very easy thing, right? Yeah, metric. How dare these guys not get to the moon, right? So I see Adrian out there. Adrian, nice to see you. As you guys can see, that was kind of the first one that one of my customers asked me, of course, is, again, this is just something to give you guys some cool pointers on, or like, again, this was a perfect example of why we do this, is they were curious. I want to chamfer this. Now, there's a lot of ways you could have did it. We could have created a sketch with these edges, extended our sketch out, of course. As you can see, by using the upper chain here, I was able to achieve the same task and create that profile coming in off my part. So I'm going to go ahead and let you guys see. Oh, hold on here. Deep Thinker, I think you can leave the units blank and get the same result. Let's go for it. I trust you. We're going to duplicate this real quick. Let's go in and do our 0.04 plus 0.140. Again, I seem to not be able to hit my plus sign today. This is what happens when you use a 10 keyless keyboard. But we're going to go ahead and hit OK. And drum roll. It looks like you are correct. We could get the same results by not having an increment, a measure at all. Hello, Ryan. How's it going? Great to see you guys out there. You guys are off to a great start today. We're in this 12 minutes minus my 5-ish minute counter, and we're up to 18 people. I appreciate it, guys. So again, it was just a little different take by using 2D chamfer. You could see in that upper rail, we've had to comp the tool down a little differently, but we still achieved the same results with the intent of being able to follow the profile that was actually modeled. So cool. with that, I'm going to go ahead and shift gears. I'm going to move over to another thing that came through. Now, this one is going to take a little bit of modeling, and I think you guys are going to laugh at how I model this, but the idea is one of my customer is milling, and he needs to put an O-ring groove inside of a bore, and he's going to do that with like a slit saw or a T-slot or a T-cutter, things of that nature. Now, what I'm going to do is I'm going to draw this up very quickly here. For any of you new in the chat, by all means, if you guys have any questions at any time, feel free to go ahead and throw those in chat. Let's just go ahead and say we have a 1.5-inch hole. And then with that, we're going to go ahead and just put it in a 2-inch block. And with that being said, we can go ahead and extrude this. And let's just make that 1.5 inches. Now, the first question they had was, how can I actually model an O-ring groove midway down in a cylinder, right? There's a lot of ways to do this. I know you guys saw me already hide my sketch. Usually I would tell people to go back and add it at the sketch level. In this case, the customer sent me a SolidWorks model, so he needed to add it manually after the fact. So let's go ahead and create a sketch on the top. And then what I'm going to do is I'm going to create another circle here. Now, I do have, when I create a sketch on a surface, for it to auto project this inner edge. Now, if you don't have that turned on, you would have to manually project that. But from this, I can now extrude that profile. And now let's say we want the bottom edge of this to be, 900 deep. Well, by changing from one-sided to two-sided, I can now bring down the other half of that, right? So let's say, for example, we're doing let's make this 200 wide so we can do it with a different size tool. I do see Max out there. Let's see here. Hold on. We got a couple of questions coming through. So I always have to mess with the top height of my groove when I'm milling with a slot cutter. I got a little bit of a secret there for you. I see probably the quickest way is to use two-sided extrude. 100%. As you're seeing me do is I am doing exactly that. We did two-sided so that I could place that groove wherever I wanted it in my part. Now let's go ahead and pivot from the design over to the manufacturer. With this, let's go ahead and create my setup. And if you guys hear any loud noises in the background, my daughter is up here wandering around. As you guys want to see, she'll come around and say hi. Do you want to come say hi? You're a little bit of a mess. Yeah, you can say hi. This is the future of jitcadcam here, guys. You can see herself off to the side, so she's a little curious. Oh, yeah, wave. Say hi to everybody. Alrighty. So with that, let's get back to this here real quick. So we have our setup. I'm going to go ahead and do the good old-fashioned fixed size box. We're just going to say 0, so it's exactly to size. And then with that, I'm not going to mill this out. It's not a big deal. I just want to show you guys how to get the toolpath on the part, right? So there's a lot of ways, and I've seen a lot of creativity. The first thing I'm actually going to do is I'm going to do a section analysis. Now, the funny thing is I think you guys have seen me do a section analysis a lot of times, but yet it's probably the one thing that shocks a lot of people throughout the day when I show them how to do this as well. As you guys can tell, my supervisor is trying to raise my desk over here. Oh, no. So with that, let's go ahead and look at a couple toolpath options. Now, based on everything going on, we're going to go ahead and do a 2D contour to start, because this is where I think a lot of people tend to start with, is I'm going to go ahead and select the lower edge here. And I'm going to go ahead and define a tool here. Now, I'm going to make up all of my dimensions. Now, you guys could, of course, pick whatever it is that you want. But let's go with 3/4 inch wide. Flute length here is going to be 100 thou. And then with that, you can see we also have a shaft diameter. Again, you're going to define your tool based off your use case or what you're buying. Now, in this case, I did tell the customer they had some 3/4 inch high-speed steel tools laying around that you could easily grind a tool for this exact size as well. So again, we picked that lower chain. As always, if you guys didn't know, one of my secrets to doing stuff here is I'm going to go ahead and hit OK, and I'm going to get a tool path on my part. And then from there, I can tweak things. So if we went ahead and simulated this right now, as you can see, we're just making one nice clean path. Now, again, yes, I know my stock is turned on and we're slamming into it, but it's not the biggest problems at all. But again, the idea is we've now set the ability to do the lower profile of that part. Now, a way you could cheat this is by splitting this toolpath into two parts. And we could have, of course, duplicated and then set another 2D contour, right? So there's several ways to select the second 2D contour. The very first way I'm going to do it is I'm actually going to pick the upper chain. And then based on that upper chain, we could go through in our heights tab and we could actually say, I want to do an offset, but I'm very much a big fan of like different tricks for you guys. What if we don't know our tool width, or our tool width is always going to change, right? Like you thought you were going to use a 100 thou thick tool, but then the actual owner of the business ordered 125 or 075. Well, the neat thing is you actually have the ability with these expressions in here. And I think a lot of people forget this. And this is where the fun of parentheses come in. But if we say tool flute length, again, we're going to times that by 1 inch. And now in this case, I know we've talked about this a bunch. 1, I can't actually put a plus sign in today. But 2, we do need that increment of measure, right? So as you're seeing here is our result is now 1.1. Well, we don't need 1.1. So I don't need a plus. Guys, I know this is scary. I'm a machinist and my math skills is out the window today. We need to multiply by 1. So as you're going to see is we're now getting a different result. So it does look like they've done some fixing here where we no longer need to do that times. This was an old trick. Some of us are old dogs to the software. So what I'm actually just going to say is tool flute length, but I do want to times that in this case by -1 so that I can get that -0.1 out, right? So again, the nice thing is here is we're using the flute length to control how far that tool goes down in my part, right? Now, another quick trick here, guys, is I know this shocks a lot of people, and I don't know why it is. I can make a video on this, and I don't think you guys would watch it. But if I turn on points, and then I could actually turn on tool and show on cursor, as well as show tool. Let's go ahead and get our tool turned off. There we go, show tool. Now, we could actually put that tool at a location on them points, right? So you can't snap to that point, but if you're visually looking real quick to see, like, is that deep enough? I can easily move my tool around and check for clearance things. Again, this is something where you don't have to constantly simulate that tool, but you can see a little different view and approach on something like this. So again, what we're going to do now is we're going to go ahead and turn off that tool. And as you can see, I'm going to do the one thing that a lot of people are probably going to regret, right? Let's go ahead and swap out and edit that tool. And let's make the flute length much smaller, right? So again, the idea by using those parameters and adjusting things is that this will auto fix the upper portion of this bore. Now, in my opinion, when doing something like this, if you guys didn't catch that, you'll notice that our line needs to be regenerated. Now, ready for it? 3, 2, 1. It's going to now move it up because our flute length is now 0.05, not 0.1. Now, when I do an O-ring like this and my tool isn't perfect to size, I still like to set an upper and a lower finishing pass. Now, what that allows me to do is to really control the width of that O-ring groove independently, right? Again, when you send this off to QA and they don't want to measure it or they don't measure it correctly, you can adjust and accommodate to them, right? But now there's some other ways to do this. And now this is another way that I've seen people do it, is the ability to actually use circle. And I think me being probably number one, I forget about circle all the time, right? Most people don't even know it's here. And how does circle work? Well, circle works the exact same as bore. And with that being said, is I can jump into the circle toolpath and I'm going to go ahead and click my geometry. Now, what you're going to notice is this is based off a surface. And as you can see by one click, we've now generated that surface and our step downs. Now, we do have multiple depths turned on, and you guys are going to see where this gets ugly. And I think this is where somebody was pointing at that, like, it gets a little messy because if your step downs do not equate to your Z heights, you're going to have a bad time, right? So again, we're going whole top to whole bottom, just like we would do bore. However, what we're doing is we're doing just a Z step down and an XY plane motion. So again, this is very, very handy at the end of the day for different scenarios. And again, this is all based on everybody and anybody's workflow, but this is my point, right? So our tool width is 50, our step downs are 40, and that math doesn't automatically calculate properly. Again, we could go through by all means, and we could set this to go ahead and do, whole top, and then we could say, flute length, or in this case, I'm going to generically just type in the -0.05. But what you've noticed is it's now shrunk it down and reduced our step downs. So if I really needed to get technical here, I would almost need to know all the information possible to accommodate everything to make this workflow work properly. This is why, again, I tend to use 2D contour at the top and the bottom, and I use something like circular everywhere else. I do see a lot of you guys out there in chat. Again, Travis, you're 100% correct, as we're starting to see. If I simulated this again, we're going to see that that tool, let's go ahead and switch from tool, hold the model still, is that very first pass, once again, is just not making contact with the part in the right area. And as you guys saw before, it seemed like it was working out very well. So again, there is a use case in a lot of different ways. And however, your max roughing step down, again, would probably be tracked back to how you set your actual step downs. So with that, I see a few questions coming in. Let's see what we got here. So probably the quickest way is to use two-sided extrude. You're right. When you literally just did it, sick, awesome. Yep, you're correct. So when we modeled this, Max, we'll go back and we can do a tapered one by all means, especially with a sketch and a revolve. Adrian, I appreciate it. Thanks, buddy. And then Ryan, what do you got? If you have a chance to go back to part at the beginning, how would you set up the stock in the middle of the part was cut out with a water jet? Oh, okay. Yeah. Sorry, my brain is just not calculating things. It is Friday on my end, guys. I'm ready to just be in the weekend. So again, as you guys can see, is you can set a max roughing step down. Again, maybe if we remove this, this is where you're going to have the trouble of this toolpath. And this is why I said is I like to do a 2D contour, you know, just to clean up everything else outside of it. And you're going to really have to play around with this to get the results. Now, if Autodesk is watching, and as we found out before, they do tend to watch my videos. Again, based on your flute length step downs, doing a lot of extra work, you can make this actually happen and manually force it. Now, it would be nice to actually have kind of a O-ring setting, or for those calculations to automatically calculate so that everything fits perfect the first time through. But again, this is one way I like circular. Somebody brought this up to me and I love the idea is, what if I just wanted to lead onto center because my tool's too big? You have lead to center just like you do in boring. So in the event that that was, you know, a 1.5 inch bore and my tool's like 1.4, I don't have to worry so much about where I'm coming in and coming out because we are coming in on center. So we could go ahead and jump back. I'm going to go ahead and jump back to the design side of this. And as somebody was requesting, we can do a bore again and we could do a spun profile. Now, if I was to do something like that, what I might do, let me go ahead and clean up this file a little bit. We did our initial extrude and then we've created our sketch here for our center. So when I did that extrude, I wouldn't actually have had this circle more or less drawing. But I can create a new sketch now. And where I want that sketch to be is going to be on that XY plane. Now, this is something I think a lot of people forget about in Fusion. There's always tricks to get to something. Is if I click and hold my mouse, my left click, notice how I can actually pick the plane based on the direction of my mouse. So I can easily find that XZ by clicking and holding my left click. So again, now what we're going to do is we're going to make a bore through the center of this. Let's go ahead and draw that bore. Now, this was a cool one too that I think a lot of people forget is we can actually, instead of doing a construction line, we could do a center line. And with that center line, when we dimension off that center line, it's going to give us a diameter. So again, let's go 125 this time. And then let's go ahead and create our taper. Now, what I like to do is use rectangles. If you guys didn't know, rectangles make it very easy to, of course, drop a line at an angle. And now let's get this model out of the way so you guys can see what I'm actually doing. Oh, and there we go. So now you can see if I was to revolve this profile, this is what we're going for. Again, you guys could dimension this a lot more, but as you're going to see, we're going to go ahead and pick our boundaries. We're going to go ahead and set our center of rotation has automatically picked up on there. As well, there is our body for the revolve move. Again, we could go in. I just Control Z'd some stuff. So we're going to go ahead and set that section view. Again, my left click and hold. I can pick that plane based on our origin. And there would be our taper groove inside of our part. Now, somebody was kind of asking, you know, like, how would you do a little bit of a taper? Same concept. If I go in with my circle toolpath, I can define everything based off that cylinder face. And because it is a circle toolpath, what you notice is it follows the surface that is driving the toolpath, right? So again, there's now tapering down inside and all of that fun. SNK, I see you out there. Hello, nice to see you there. So you could, 100%, Michael, you could, instead of using circle, if I actually went in and I did a bore toolpath instead, again, you're going to have to play with your Z heights, of course, but notice how I'm helicky boring down inside that part, right? Now, keep in mind, your first initial pass of that bore one is always at a taper, right? So you would still need to do an upper kind of 2D contour to clean up that top edge. Again, I can fix this here. We need to redefine our edge. And as you guys can see, we can now set that top edge to clean up that upper lip. This is why the bore may not be the best of choice. Maybe this is another point for Autodesk to step in and say, hey, I want to make a finish pass at the top as well as the bottom when we've completed everything. But that would be another way you could draw, extrude, or actually revolve, and then machine down a taper bore as if you're doing it in a CNC mill. Keep in mind when you guys post this out, you could post this with polar milling too if you had a C-axis. Completely doable. So let's go ahead and jump back and move over to the other part. Now, somebody was asking, what would you do if this was something that was basically water jet out, right? So I have a rough profile for stock that I need to use inside of Fusion. Now, that's a really good question. So what I'm going to do is I'm going to jump back to design. And what I need to do is I need to create that stock, right? So if I was to create a sketch, I'm going to throw a sketch right on top of my part. And then what I could do is, again, I could drop my rectangles. Now, I'm going to do this very loosely to give you guys a pretty good idea of what to do. And with two rectangles, I can basically create that C-channel shape for my rough material, right? So with that, we'll now do our extrude. I'm going to grab all of these boundaries. And then I'm going to do a two-sided extrude. And the reason why I'm doing two-sided is we may want, you know, like 100 thou stock above. And then we want to go down to the bottom surface and maybe go, you know, 100 thou past, right? So that's 1.5. Let's just go 1.6. And then we're going to do a brand new body. Now, you can see with a new body, I have my old part kind of floating around in the background. And a trick that I personally use all the time is go to that body or component, and we're going to relabel that as stock so that we know. But I like to change the opacity so that you can see the ghost image of the stock versus the part. So as you can see, somebody is mentioning it out there, your desired method is for water jet stock, so it projects the body and offset the sketch. Yep, 100%. So you can do that. I'm just doing a little bit simpler, but because you would have had a projected sketch, you could extrude that, Max. But again, when we go into our manufacturer side, one neat thing about Fusion is we could actually do water jet in Fusion. So I'm going to ditch this setup. And let's start. Our first setup is going to be based on cutting. Now, cutting is water, laser, or water jet. My XYZ position is all jacked up, so let's fix that. My model to be manufactured is going to be that stock model. And then we're going to go ahead and in our stock, now our stock is technically the exact same model that we're going to machine. Or in this case, we're going to water jet. So I'm going to highlight both. Or if you wanted to set this up as if it was a sheet of material, we could, of course, go through and, you know, say it's like 48 by like 96. Or we could nest this out, of course, and we could offset, you know, back left, quarter of an inch or something. Again, the idea here is I'm giving you guys the absolute bare minimums kind of thing or a rough workflow. But now that we have that, we can, of course, go in and hit our 2D profile. We're going to select our tool. Now, depending on your water jet or your actual laser, may use a kerf width, right? So make sure that either your machine has a nozzle diameter, a kerf width, things of that nature. As well, your speeds and feeds might be controlled at the controller. So if you're on like a flow, when you tell it the material, that's when it tells itself the speeds and feeds. But just know you can add that stuff in at any time, right? So again, we're going to go ahead and grab that water jet, my profile to cut here. And then with that, basically that's it. And there's my water jet profile to cut out my stock. Again, we now rinse and repeat here. What I'm going to do is I'm going to go ahead and do a setup again, Z-axis up. This time my stock is going to be this solid. So let's go ahead and stock from solid. My part model this time is actually going to be back up here, a little easier to get to. And there it is. Now, what you guys are seeing me do in the design tree, there's a reason for it. And you're going to see why here in a minute. Because I actually have my synchronizations turned on. So when I hit OK, notice how one, it got rid of my solid body, but kept the setup stock. And then two, it turned on my other body. So if I'm jumping between setups, notice how I can automatically set this up to present itself so that I can see whatever it is I'm latest and greatest working on. And how you do so is down here at the bottom under synchronize. I go ahead and tell everybody check all three of these so that you can go ahead and jump from one to the other quickly and see that turned on. Bogan, I see you out there, man. I will go ahead and check my email here in a second. But again, the idea is now that our stock is here, if we were to do nothing more than like a 3D adaptive clearing toolpath, and from what we know, they fixed it here. Again, you guys know me. Maybe I should change my name to half-inch flat fill, right? Flat end mill fill. But we can use that to our advantage, again, because the automatic detection of where the stock is versus where my solid model is. And as you're seeing, that machining comes through for me. So I'm going to go ahead and run through all these questions here real quick. Let's make sure we didn't miss anything. Max, I hope that helps out to see that in Fusion you could do all of that. And with that, helical is useful for better surface quality in that groove. Yep, no problem, Michael. I appreciate it. And you sent me two to my email. Awesome. I see 20 of you guys out here. And let's go ahead and get these downloaded real quick. And with that, let's go ahead and jump back. So make sure nobody's messaging me in Discord. And where's our Fusion? There we go. So now that we're back, let's go ahead and upload these two files. This is where I get put on the spot and you guys get to see me crash Fusion, right? This is what everybody joins for. "100%, Ryan. It's a neat trick, as you can see, is if you can, again, another way that I've seen a couple of shops do it is if you have an old, like, Bridgeport mill and you want to rough machine something there, that works out really well, too. Using a router to cut blanks. I've seen it any and every way possible. All right, so we got FS1 and FS2. What do you got for me, Bogdan? Some good old letters. Always. Always with the engraving. And you put a lovely part here for me. So let's see what we have. And let's pull up FS2 here. So how to finish the wall in the slot. Oh, all right. No problem. I like how you put the text there. I thought I was supposed to do the text, not necessarily do the actual path itself. But I love the text on the part. You're top. You're above, way above me. I didn't even read the text. You notice my brain was just like, oh, I'm making engravings, right? So, all right. So how can we finish the wall inside this slot? Well, this one's actually pretty easy and I like it. So, of course, looks like you even put a setup in here for me too. Look at this guy. This guy, I don't know who this guy is out here, but if I was hiring, this would be one of the guys on my list. I would actually do, as funny as it is, a trace toolpath. Now, if I know the radius of that actual surface, in this case, I don't, we're going to go ahead and inspect, and we can pull a dimension, and oh, here's the problem. Never mind. I take back what I said about possibly hiring this guy after seeing the millimeters here. Is, as you can see, it's a 2 millimeter radius. So you guys are going to watch me use good old metric tooling here. But 2D, we're going to go for a trace. And now what I'm going to do is I'm going to go into my tool library, and I'm going to probably go take a shower after this, having to do this. Oh, thank goodness. We don't have a 2 millimeter ball. Well, we're just going to steal one of these, and we will just go ahead and change it, right? So edit. And so that you guys don't grief me in emails, we'll do this the right way. Again, this is now a 2 millimeter ball. And with that being said, that should auto-calculate. Awesome. So there's our 2 millimeter ball, right? Now, I'm going to go ahead and pick my curve. And now there's a lot of different ways to pick the curves. Now, keep in mind, this tool is going to machine on center line because it, by default, does not have cutter comp. So I can use that to my advantage by picking this edge here at the bottom of my fillet. And then, of course, we don't want to start right on our part. So let's go ahead and extend that out by 2 on both ends. And as you can see, that tool is now going to come in and it's going to follow down through that pocket and back out the other end. Now, if you wanted to do this with a couple of step downs, by all means, guys, you could, of course, go ahead and add multiple depths here, whatever you want that to be or whatever you want to calculate. And again, as you're seeing, we're now doing multiple depths across that surface. I see a lot of you guys taking off in chat. I also think, we're at 22 people. Let's see if we can get to 22 live people all at once. So, Travis, I see you out there simulating. You can save the stock, and when you go to the next op, you can set your WCS off of it. Well, let's jump back to that real quick. So, when you're done simulating, you can save the stock. You can do that, Travis. The problem is that STL is laying in the background of Fusion. So with the continuous rest machining, it might be a little better scenario, but I would tell you that if you're really, really, really going for it, it'd be worth almost taking that STL and instead of doing that is finding a point and sketching it out. Because the older way, if you guys didn't know, is if you simulate something like this, right? So let's turn stock back on for the sake of this. And we really want to get to the end of this. I know we're going to have collisions, yada, yada, yada. But what Travis is talking about is you have the ability to right click, go down to stock and save your stock, right? And what this is going to do is this is going to create an STL of your stock that you've machined. Now, this was an old way of doing things and then bringing the STL back in. I would say with continuous rest machining and everything, it tends to make life a little bit easier for setting everything up. So if I was to actually take this part and duplicate it, and then we're going to go ahead and flip our Z, and then our stock is going to be from proceeding. And of course, we have our continuous rest machining turned on. But if we went in and said a stock box, we're still rectangular. And as he's talking, what about a selected point? As you notice, I can't select something on my stock here. So I would be forced to either have modeled stock. Again, we do luck out because I do have a model for stock in the background here, right? But that would be, again, a different way to go around what you're trying to do is if you started with a model of stock, you could then use those hard edges off that. Now, if you're looking for a very weird point, I would tell you there's a workflow I'll show you guys. I would have to show you personally to be able to achieve that, but that should help you a little bit more, right? Well, let's go ahead. I'm going to run through these questions real quick. Sent an email. All right, Deep Thinker, I'll get to that here in a second. That was fast. What did we miss out on? That was fast. You saw, oh, I know what we're talking about. When yours truly went through and did the trace toolpath there on that edge. Now, keep in mind, if you guys wanted to, there's nothing wrong with this, but what I'm going to do is I'm going to unselect those edges. And if I wanted to go through and actually use the upper rail, again, we're going to have to comp this down here in a second because we are going to be based on that upper area. But if I wanted to use cutter comp left, for example, then I could, guarantee being able to bump that tool in and out as needed. Now, again, this isn't necessarily a finishing strategy, but it is. We don't have cutter comp in this tool path, so we would need to use stock to leave to control cutter comp or add a D when we post that out. But the idea is in my heights tab, or actually not my heights tab, I apologize, guys. This is where we're going to use an axial offset, right? So if I know my tool is a 2 millimeter ball, I need to offset -1 millimeter. And as you can see, we could bring that tool further down to machine in our part. And in this case, I think I actually need -2. I think my brain is working backwards because it needs to be based off -2. But as you're seeing, is we can bring that tool down with the axial offset to get it pushed into our part. Again, because we are using cutter comp left as well, we need to make sure that we're compensated far enough away. So I hope that answers your question on this first one. I'm going to go ahead. Let's just double check my questions here. And sometimes the model moves and the sketches don't follow. Travis, I'll show you something about that as well. That's because you're not using components usually. Is there a way to do this with a bull nose end mill? There is a way, technically you could. It just depends on the size of your bowl. I assume your bowl is going to be about the same size. But if you were to do something in this pocket and you were going to use a bowl end mill, I would recommend actually switching to like 3D contour. Again, if we go through with a bowl end mill, so let's go ahead and pick one out of our library. And let's just say it's a 4mm. And now what we're going to do is we're going to define our geometry. I'm going to just do a selected boundary. Cool, simple enough on this part is going to be inside boundary. And then we can set our max step down to whatever it is. And as you're going to see is we're now going to use a 3D toolpath to run around the inside of this part. And again, create that fillet. More step downs, the better, of course. But I think that gives you a little different approach by using a 3D toolpath to accomplish that same kind of task, right? So let's jump back over to FS2. So is there a way to probe the smaller diameter in this orientation? Well, technically, yes. So if we go into manufacture, we've already got my setup again. Man, I tell you, you are making this way too easy on me. So what I'm going to do is I'm going to go ahead and jump over to the inspection tab. Now, I assume, are you trying to do a probe WCS or are you trying to measure a geometry? Because what's going to be hard is with doing probe WCS, it's not going to pick up that bore in a Z-axis. But if we were to go in and do a probe geometry, you could see by picking that surface, it's now created all my points of reference, and I can offset that to wherever I need it to be. So again, what I'm going to do is go through, and you can see we've created our points of measuring, and we could use that based on our probe. So give me a second here to pull a probe. And as we come down, we're now probing all of that area on our part. Now we can move that feature, and this would be measuring at the end of the day, right? So again, we can change our position. In this case, let's say we were at 10. I might have to run through this a little bit to see where we move our position. Oh, picked the wrong surface there. Go ahead and go back and pick. Let's see what it's going to take to move this down our part, right? So it doesn't look like that is doing it. Let's go ahead and pick a different place and see if we could shift that down. Height plane, number of points, approach over travel, position. I do see you need to measure that. So again, what we're seeing here is the ability to measure using the probe. I'm just quickly trying to figure out if we can shift that down our part or not without spending a ton of time here. But I think you can see by using probe geometry and using that cylinder face, we could definitely go in and measure that coming in on Z vertically, right? I'll have to make a new probing video because that's a pretty good feature. I did do, I think it was a Fusion Friday probing video where we go through a lot of this. So let's go ahead and scroll back up. All right, Deep Thinker sent us a model. And is there a way? Yep, we did the bulldoze end mill. Sketches don't follow. You would like to, all right, so Roy's got one. Roy, I'm going to put you on my list next, but let me go ahead and jump back and see what I got for a part that has been sent in. I'm going to go ahead and download this part. Deep Thinker, your name is Tony, correct? I just want to make sure. 24 people. We're getting closer and closer. It's always fun to do these videos, and to be honest with you guys, I get like 150 total views when we do the live, and then I come back and look at the video on like Tuesday, and there's like 500 views over the weekend. All right, cool. So I'm going to go ahead and upload that part then. I didn't want to get too crazy and throw a part up here I'm not supposed to. You guys got to keep in mind, your names on YouTube versus the names that you email me from can be way off, right? Way off. All right, push rod, push rod, push rod. That was not the push rod I was thinking was going to come through. All right, good times. All right, you want to give me, Deep Thinker, you want to give me a run around here? Let me go back up to what you're asking. Trying to avoid cutting air or machining more than the flat face. So are you just trying to machine across this flat face is what I'm understanding? Did you just message? Yep, I'm sorry. I was scrolled up trying to read through. So if you were trying to machine this face, I see this quite a bit, is it looks like he's got something here, but he has a bunch of fun settings going on. So there's a couple of ways you could get away. All right, cool. So there's a lot of different ways to do this, but I've seen this a lot. And if you guys notice here, if I click the edge of that flat that he has, is the chain wraps 360 degrees around the part, right? Like it goes all the way up and around. So that in itself could cause some problems as he's starting to see. So you can't really do a clean 2D contour. Now he's attempted it. And if I click his 2D contour, notice how this wraps up and around, right? So this is probably giving him some problems on how to actually grab that chain and not get errors, right? So there is a lot of things that we can do to fix that. Now, I am seeing some people talk about avoid touch machining, 100%. So if we were to go 3D contour, and I'm going to wing this, we're just going to go for it. And I'm going to say a silhouette. I want the tool all the way outside of my part. And if you guys can guess, or if any of you caught my video last Wednesday, and next Wednesdays will be about milling, I'm just going to hit OK. And I'm going to make sure I get a tool path on my part before I really start messing with anything, right? So one thing is in the world of Fusion, if you paid for the extra features, we could actually cheat. And I mean cheat because I could go in and I could trim toolpath and I could say, you know what? I only want to keep everything in this area. And in this case, I intentionally boogered that up, but let's see who's bothering me in Discord. Give me one sec here. So as you guys can see, I trimmed it and I actually said stay outside that boundary, right? And with that, if I go back to that trim at the bottom and I say inside only, as you're going to notice, I've now trimmed it to only machine in that one area. Now, I could get more technical than that, or I could not use trim toolpath. The idea would be, as some of you have said, is what happens if we start to give this, avoid areas, right? So we could go in and we could say avoid. And now what I'm going to do is I'm going to pick that cylinder. And then I am going to pick the tip as well. But let's go ahead and hit OK and see what we get to start with, right? So as you're going to see now, we're getting that toolpath much more at the end of our part. Again, this is looking a lot cleaner like what we want. Yes, we're still machining stuff at this end, but as you guys seen, we could easily go in and say, you know what? I don't want to machine any of these additional surfaces. So let's go ahead and pick the right group, of course. Oh, let's just double click it. And there we go. We could add all of these features in here at the end. And now you can see they have all showed up on red, limiting our toolpath to just this one end of the part, right? I do need to pull back up my chat. Travis, you were right. Avoid touch machining made that quite a dream. Now, if you weren't looking to use avoid touch machining, you could also do this in a simpler fashion where if we went back to design, this is a really cool trick, is one, let's make sure we have a plane that is perpendicular to that face. So what I'm going to do here is I'm actually going to go in and I am going to split this body and I'm going to split it using that surface. Now, this is a complete way to cheat about this because now we have two parts here, right? But what I also have is one very straight line. And as you see, by cheating the system, there's a lot of things I could do. But if you think in the world of Fusion's timeline, if I was to create a sketch on this surface real quick and then throw a line at this, what's going to happen is we now have that in our timeline. And then I'm going to wrap up my timeline by cheating and combining those two back together, right? So as you can see, I just completely cut my part in half. I put it back together. And while doing so, I stuck a sketch in there using that flat profile. So again, we go back to our manufacturer. I'm going to go ahead and have to reselect something here because you're going to notice, actually, it still pulled that whole body through. Awesome. But if I wanted to do a 2D contour, again, as you can see, is it's giving me that silhouette profile I just created. I'm holding the Alt key to give it one edge. Again, we're going to go ahead and reverse direction. So our red arrow is outside, maybe extend it off our part, whatever our distance is. And again, we could change our Z heights, but this is another way to completely cheat the system, right? It's all these little workarounds I think you guys absolutely love seeing. So how does that look for you out there, deep thinker? Yep, I figured the part was already turned by the lathe department. It'd have been nice if it was turned in Fusion, or maybe you didn't provide me the turning side of it. If you guys want to see why that is, I'll show you here, because I run into this a lot where a lot of shops are still using manual lathes, or they have a guy on the Mazatrol. These guys, they're Mazatrols, I tell you. Nothing against them, but they hand program everything with the intuitive program, and then you got to do the cam for milling, and it comes after you and it bites you in the butt because you don't have a model to work off of. Max, you're 100% correct. Adaptive clearing would work very, very well, which is something that I think he started with here. And again, is you're seeing adaptive clearing go all the way around the outside of the part. And the reason is because you do have a lot going on here. But I would say is when we go in and look at your setup of your tool path, is he has model turned on. He actually doesn't need model turned on. Now, his stock definition shouldn't be a silhouette from setup stock. It could just be remaining stock. Or we could define a model. And in this case, if we had a stock model that was appropriate to use, this is where the getting into the world of using a little different workflow could help him a lot. So we're going to go remaining stock and we're going to hit OK. And I think this is going to be a good candidate for any of you that was out here. Again, we're seeing things at the end here. And the reason why we're seeing things here is because I said from setup stock. And then we're machining everything down here at the end. Again, it is recognizing some stock here. So if you guys didn't know, last week, we looked at a bug fix that I believe was pushed by turning on reduce air cutting. Might be able to fix what we have going on. Good, buddy. Thank you. Had to get my energy drink for the beer call out. So again, we're going to give this a second to think about it. You can project a spun profile in Sketch. Yes, you could do that. Another thing, again, guys, this is why I say, is one of those things I was saying is if this part would have actually been set up inside of Fusion and actually turned on a lathe, right? So what I'm going to do is I'm going to very quickly throw this together. We're going to say fixed size cylinder, and we're going to round up by 0 just so we can turn the end of it, right? And then let's drag this up to the top. And then what I'm going to do is I have a lovely little template we'll sprinkle on this. And just like that, you're noticing that we have now machined the end of this part, right? So again, we roughed it, we finished it, but now I have that stock model that is transferred through. And I think I have my stock model turned off. There we go. So now you guys can see that green model is my stock that we've machined. So when I roll into my second setup, my stock is actually from proceeding. And we want continuous rest machining turned on because all of our additional tool paths from there can be determined and utilize that to an advantage, right? So I do see some other things coming through. I usually save my body before I start adding my mill features. That way I can use a solid for my stock. Yep, 100%. Or as you're seeing, rest machining can do a lot for you. Let's go ahead and kick off the reduce air cutting and see if it gives us a better tool path. In the meantime, while that calculates, oh, we are at 25. Let's go. Record high. Of course, Fusion puts me in a really bad spot. So we're going to come back to this in a second. But I do want to tell you guys, obviously, everybody loves coming out and watching this. I appreciate all you guys and viewers. You guys have supported me in a ton of ways, whether it be, the likes, the subscribe, sharing my content to other people. Of course, there's other ways to support this channel if you want to give more. We do have, I think, Super Chat set up now. We also do the Buy Me a Beer program. If you're in North America, you can make us your jitcadcam as your reseller of software, meaning you transact with us versus whoever you may be dissatisfied with, assuming that's why you're moving. But we do a lot of other things, everything from contract programming. And I got to say, this week's beer/energy drink goes out to all of you guys. So let's go ahead and jump back into this. Oh, I almost forgot. You guys haven't seen, we're also doing the either give it to us or give it to the government 20% off sale on all services between now and the end of the year. Now, the beer is not 20% off for the record. You can't buy beers at 20% off, but any of our training and our support packages are. So let's go ahead and get back to this. If I can push the right button on Steam Deck while I grab a drink. So all that work, Deep Thinker, I know you were really fighting the system and trying to do a lot. But as you can see, had I just put a couple of lathe tool paths here to fake the system, as you can see, the first thing my adaptive clearing has now recognized is where there is stock and where there isn't stock to be able to go in and machine things off, right? So this is something that is, again, night and day difference when you're simplifying and actually adopting the software more than most people think. Now, I do see this, again, if you have a manual guy on the lathe and he's going to turn the end of this part, this makes it way easier. So, Pompeii Boy 5, how do you buy beer from the UK? You could actually do a super chat. So I think down at the bottom, there's the ability to do either a super chat or you can do a super sticker, I guess. I haven't figured out how to upload some funny stickers. I plan to, but is it me or is 3D adaptive crash fairly often? So TC, I appreciate that comment because I hear that a lot. Now, I don't seem to have a problem with it, and I don't know. I do know a lot of times, and I'm not saying it's the nut behind the switch, but if you guys ever see me program, and I'll show you an example of this, right? Like, let's say I'm working through this part. If I'm going for adaptive clearing, I'm just going to give it a tool, and I'm going to let it do what it's supposed to do. What I commonly see is a lot of people go in and start clicking a million things right off the start. And then you put in support tickets to me, and then I have to do exactly what you saw me do there, right? I don't care about step down. I don't care about any of that. That's easy to add. But by looking at what the software just did naturally for me, I really didn't do anything. I didn't. Like, it actually is trying to progress this part for me, right? That's kind of a neat feature that I see. Now, if I would have went in here and I could, by all means, probably try to make it crash and, you know, instead of using stock definition, I switch to this and I turn on model and then I'm changing my heights and then I'm changing all my other stuff, it could possibly crash. Now, speaking as a lot of time at using Fusion way back in the day, yes, adaptive clearing as a whole could actually make it crash. I haven't seen that at all yet. So as I can see, let me go ahead and scroll up here a little bit. I want to make sure I'm not missing any of you guys. Deep Thinker, I hope that helped you out a bunch. I'm going to go ahead and undo some of the stuff I did so we could reevaluate a few things going on here. Again, we use that 2D contour to be able to pick up that edge. I've also did it with a 3D contour, again, for my finishing passes, and that's using adaptive clearing to start with. So from that, we have, so Pompeii Boy 5, I can't say that without laughing. I'm sorry, man. That's a good one. You know, I play video games still in my old age, and my naming video games is Remy the Rat, so I get it, man. Again, 3D adaptive clearing crashing, I would say that comes back to also your computer hardware a lot of times. If you don't realize that you can see how much data a file starts to become very quickly, it's a lot of small arcs and stuff, and that has a tendency to cause problems as well. Is, again, I would need to see the use case, but if I was to stack, you know, 8 or 9 adaptive clearings on top of each other with rest machining, you know, it could crash. I don't think it's going to. So I see Brandon out there have an issue with a part that was drawn to the low end of the print tolerance and not nominal. How would you like to program it? Is there a simple solution or do we have to alter the model? So there is a couple of solutions, Brandon, as I'm going to show you here. So this is actually a good part to look at. I'm going to go ahead and machine. And in this case, I think this is probably one of my favorite things, right? So I'm going to go ahead and move this toolpath up for a couple of reasons. Is one, I want my clearing right after we do that adaptive, right? And what I'm looking for is visual representation to all of you. Is you're going to notice we're roughing this part out. We're leaving 20 on the walls, and then we're cleaning up the wall, right? You see this lovely little step still there because we're not machining all the way down that surface. Now, based on your tool paths, I'm actually going to have to do this with 3D, is in that tool path, you can actually avoid a surface. So what I could do here is radially is I could add 10 thou to specific surfaces when machining. Now, I don't know how simple or hard your parts are, of course. Let's go ahead and go back and fix that one more time. So let's bump that down to about 5 thou. We should be able to machine that surface. Of course, it's giving me problems without touching any of the other surfaces. So as you guys see this in real time, it happens quite a bit. Is I'll have to play with that on my end, or maybe we found a bug that we're really good at, is being able to use not only avoid surface, but stay away from surface logic. But if I was to be machining a part, let's say, again, on a lathe, and I need to stay away from certain surfaces, I could use stock to leave as well, right? So in the event that I'm going to use my passes tab, we could say stock to leave. And then with that stock to leave, that would give you custom compensation for certain areas of that part. Now, another way you could go about it, of course, is taking a model. And we'll do this here real quick, a good old-fashioned copy paste. And then on that second model, I could go ahead and do something like press pull. So again, is if I needed this cylinder to be a little bit bigger, I'm going to make it 100th thou bigger. You can see my original part still in the background. For all of you out there, let's go ahead and kick on our opacity. Again, you can see the original part versus the modified part. Again, in our toolpath for certain operations, we may want to add in that model to be able to manufacture it. Now, in the lathe, model is based off edge selection. So this is, again, something super cool that you're seeing inside of Fusion, where we're not going to use a solid model, we're going to use a sketched edge. So what I would need to do on a lathe is actually place my model in my setup, right? So again, I'm going to go back to my setup. I'm going to pull that second body in. Again, now regenerating that tool path. And what you'll notice is we're now machining that larger body, which I'm going to turn off temporarily. So we're avoiding that area and then still machining everything else. Now, if you were doing this on the mill, the same rules kind of apply if you need to stay away from certain surfaces. I do see some other questions coming in. What's the issue? So the issue in between the keyboard and the chair. Yeah, from time to time, you could say that. I like that one. That's a good one. In all my years of training people, I will tell you guys, I don't know what it is. It seems like the pricier the software, the more sometimes the computer illiterate the person is learning the software. And it is a blast to train people. Don't get me wrong, but I've had some scenarios where I have to tell somebody like, yeah, you just have to go up there and click from design to manufacture. And you know what these people do? They look at the computer and then look at their hand and then they move the mouse. And then they look at the computer and they look at their hand and they move the mouse. And you can just tell, you're like, yeah, maybe you need computer 101, right? So I'm going to go ahead and continue on. Matthew, I see you out there. You always press generate with the tool and adjust after. Yeah, dude, I mean, in lack of better terms, we call that throwing crap at the wall until it sticks, right? That's my opinion on it. Just get a path on your part. My Wednesday video explained it. Like, Fusion's color-coded, guys. I don't get why people, like, try to overthink it, right? Like, I want more blue lines. Well, if I look at my toolpath, where's the blue lines? Oh, it's in the passes tab, right? And then I can go in and, I could adjust, my maximum depth of cut or whatever I'm going to do, right? It's one of the fun things to see. Yeah, I mean, Andreas says it correct. He makes everything to 99% and the press pull to make everything to the mid tolerance. That works quite well. So I like Travis's question. He actually has a pretty good question. I'm going to stay with this part because it's going to work pretty good for us. So what we're going to do is we're going to actually say this is maybe a 1.75 stock. We'll need to fix my good old-fashioned roughing here because we probably wouldn't be doing vertical passes. We'll be doing horizontal passes, right? So what he's asking is a use case where maybe your customer is calling out the idea this is going to have a press fit bearing. So he wants a 32 finish on this end. But yet, can we do like a 125 finish out here on the outside of the cylinder? Well, the thing is you can't actually do it all in one toolpath. We would have to split things up, right? So what I would really need to do is use my geometry and then from there, select my back position in here. So I would need to constrain my toolpath. Again, go watch my Wednesday video, guys. I need the view count. But I'm going to constrain in my Z-axis where I want that toolpath to go. Now, again, a little pro tip for you guys out here is you can see this toolpath is going to come up this face and immediately stop and come out. Well, if you are to set a tangential extension here, it will follow the last edge used and continue out your part away from everything else. Again, deburring that nicely as you go. But as you can see, I would have to take that tool path. There would be my first go. I don't have 2 sets of speeds and feeds on this tool, guys, but let's just say, what is this? A 40 thou feed per rev. And then I would make my second one. Of course, now we're going to go ahead and start with our selection for front. And then we're going to go all the way to the back. And maybe this time we're going to use, you know, a 20 thou rev, right? It would be nice if you could break up a tool path into multiple segments and still use one chain. However, in this case, not so much. There is a couple ways around that, though. And what I could do is, instead of having my tool start all the way out here, you guys could actually change your approach and say first Z, last tool point. And then that will actually bring your tool in. And as you can see, it will actually start from this position and come out here without all that additional rapiding movement, right? So if you're really looking to speed up some cycle times, we do our first and our last point. And again, now you're going to see we come down and around and out, and then immediately we could jump right into that next tool path and go down that shaft. So again, it's a little bit of a trick for you guys to jump around, change things up, and all of that. Any other questions for you guys? We've been going strong for an hour. I feel like I just get up here and blabber, 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 blabber. You can add a bigger lead in and set the front of the tool path to further into the part. Yes, by all means. Andreas, I see you out. The tool before you can go to approach at the last tool path. I assume you are, let's see here real quick. Yep. Brandon sent some files. Let's go ahead and pull up these files here. I see you guys kind of popping off chat here a little bit. Of course, another one of my customers just emailed me on something I can't show you guys, but let's see here. Let's go ahead and get these downloaded. Oh, we got a drawing and a step file. All right, let's get this uploaded. If you guys didn't know, some people don't, you know, you can upload your actual drawings into Fusion too. So you can keep that PDF drawing as well as your original part sitting here. All right, I got to get back over to OBS. So, Travis, that's another really good question. Setting your turning tool to cutting edge instead of contact point. You set it as a user default, but you always have to do it again. Well, one thing, Travis, I do have to point out, and I think a lot of people overlook this, and what he's talking about for any of you out there, this is a drop-down menu. So instead of using contact point, he wants to use cutting edge, but he's having to change it all the time. Now, first off, you can go in and click the 3 dots and save as user default, right? So then that will be the standard. But keep in mind, that's only a user default for profile finishing. So when you're looking at any other toolpath inside of Fusion, if there's an option to change that, which we won't see here in facing, of course, but in your other toolpaths, you're still going to have to go in and set that as a user default. Now, there is a little bit of a funny thing here where you could actually export your defaults. I think a lot of people overforget this, is if you export them, they will come out as a CSV file, and you can open them and modify them. See if I can find mine here real quick. Where did that go? I might have to re-export them here. Do that again. Of course, it went into the good old-fashioned Fusion file, right? And I'm going to open mine up in Visual Studio Code so you guys can see it. But this is going to be a lot of your defaults for Fusion 360 and being able to bring those in and change them out. Now, there is a lot here, and there is another spot where they're all being dumped too. So we would have to open that file up. And I think I'm going to keep that a secret because I think that's a really good one, Travis, to cover on a Workflow Wednesday. You guys are out there arguing over mills and lathes. Love it. All right, let's see what we got. course, it's a turning part. One of my favorite things ever, right? So I am going to open this drawing up. I am going to have to bring it over for you guys here real quick. And I just wanted to show you again, with the Fusion viewer, you can actually view PDFs. So as you can see here is I can go into Fusion 360. I can look at this drawing, review everything that needs to be done here. As well, going to actually open this up on my other screen in a PDF. A little easier on me, and we're going to see where we need to change some tolerances. So where is the fun call out? I think it's probably that absolutely brutal inside diameter that I'm seeing with 4 decimal places everywhere. So let's go ahead and verify that real quick. Again, we're going to go ahead and I'm going to jump to manufacture. Actually, we'll do this in design. We're going to do our section analysis. Again, split our part in half. And let's inspect this guy right here, because this is where I think it begins, right? So we are 5.5075. And we need 4 decimal places. So in this case, it actually has you right on the money. Now, let's go check another spot. Oh, nope, he's got some red circles here. All right, I see what you got going on here. Give me a sec here to find a relative setting. Okay, so the case is on this part is it's 139 plus 6 minus 0. And that location is right here from flat to flat, right? Go ahead and reselect those. So right now it's set to 139 exactly. Now there is a plus 6 minus 0. So it can presumably be bigger, but it cannot be smaller. Now this is something good that when you're using the grooving tools of Fusion, now this feature in itself could be compensated very easily by utilizing our stock to leave. And for my stock here, let's just go ahead for a cylinder. If anybody out there is saying anything in chat, just know I can't see you at the minute because I am over on my other screen. So fixed size tube. We're going to go ahead and flip our Z. And if we were to bore out the inside of this part, again, Autodesk, if you're watching this, I know it's, 6 in one hand, half a dozen in the other. If my analyzes would have came through from design to manufacture, it would make my job much easier, right? So again, we're going to do our section view. Our x-axis is pointing the right way so we can see our tooling come in. But let's go ahead and just do our grooving. Let's pick our internal grooving bar. This is where we all come to figure out that I don't have the right tool. And with that, we're going to go ahead and set our front, back, and we should get some type of grooving path that's probably going to look terrible, and we don't need to look at stock, right? As you can see, my grooving tool is going in. It's grooving everything out in there. Again, as we've kind of just talked about the whole concept of our contact point being displayed. But if I was at 0 and I have allowance of 6 in a feature like this, I could easily come in, like I said, is use stock to leave. And what I want to do is I want to change it radial, right? So I could bump it up by, in my case, I'd probably go 1.5, giving me 3 overall. And that would put me right in the middle, right? So a feature like that, very easily controllable with stock to leave. Now, I am going to pull up my chat again, make sure you guys aren't hassling me like crazy like you guys do. So I can't say that name. We'll come back to that here in a minute. So as you can see, we very much were able to adjust the actual settings there on that feature. Now, there is additional things, and I think this is where things get really, really fun in Fusion, is somebody brought up the idea of, what if you use press pull, right? Well, in the world of press pull, if we start to bring that back, you're going to notice that feature starts to change sizes, right? So we would need to be aware of that in the event that you guys are trying to open something up or shrink something down. Now, based on what I'm seeing for tolerancing on this part, though, we could easily come in and pick our 2 surfaces, again, set them to like 1.5 thou bigger. And that would open up that gap for us to be able to machine it, right? So that's one way you could do stuff like that. Now, another really cool way I think some people forget about is you can do a move, and you can move faces. Now, sometimes this works, not always in some cases, but as you can see, I can drag the faces away from my part, right? So if I wanted to give this a certain amount, let's say I want to go minus 0.003 in this case, you can see how I can grab that surface and drag it, opening it up. And now if we measure that, you're going to see we're at 142 versus 139 before. So I hope that helps you a ton with, who was it that asked that, Brandon? That's a little different way. I know it takes a little bit of modeling, but by forcing the model, it tends to help you longer in the toolpath. There is also the third option, which is a sketch. On a lot of the toolpaths inside of Fusion, now you have that ability to use model and actually use a sketch that you created. And I know a lot of people that do that well. So again, as I'm seeing, guys, I'm going to scroll back up. Let's look at some of these questions. So can you force the developers to make a 2D outline strategy only with a radius? That's a wild one. I would need to see an example of what you're trying to do. "2D contour only for radii so that it can only use G42, G41. Can you send me an example? I would like to see exactly what you're trying to do and if there isn't a different workflow. How would you have a tool automatically check for breakage and wear after running a certain amount of parts? Well, so if you wanted something based on a macro on your M30s, there's a couple ways to do it. We've modified post processors for things like that. The easiest way, if you guys have never seen this inside of Fusion, let me get back to a little different part here, is as you can see, I have my part here. Let's say we were doing our 2D contour, and let's just put one right at the end, right? Let's just make this as easy as can be. Obviously, our part's upside down, right? Well, in our tool, if we edit this, if we edit the tool, there we go, is in my actual post processor tab, I can say break control. Now, what's going to happen with break control is this is going to go based on my post, is go probe itself after it's used, right? So when I go and post this out, if I could find post process, let's go ahead and throw this at, what do we have for files in here? Nothing good right off the start. And I've got a million different ones that are all edited and teared up, so we're probably going to have some problems today. We'll go with the Haas Next Gen. Now, again, you have a tool breakage tolerance that you're going to set here. And what that is going to do is we can go out, is we can create that G code, which is going to spit out our macro, if we're lucky, to check that tool. However, I'm not seeing it here. We've used that tool, and it may not be in this post. Let's grab another post here real quick. Got a lot of modified things from you guys asking me these wild questions. I need to clean house on all of this. Again, we'll go Haas, Next Gen, Control. Copy it. There we go. Break detection. Awesome. And let's see if we get that code that we're looking for. And we're not. So we may have to turn something on. Check here. Let's edit our tool. Let's make sure I'm not going crazy. Again, we have break control turned on. Awesome. I wonder if they changed it to make it where I have to force it. If any of you guys know what I'm doing wrong, feel free to speak up. Let's go ahead and pop this post out. Basically, what I'm looking for is this is the actual code that's going to get dumped out of Fusion in order to write that cycle for break control. What I would recommend, who was it that asked that question? Ash Designs. If you're looking to broaden this to do it after X amount of M30 cycles or something of that nature, you 100% can come in and program that up. Now, again, depending on your tool or your machine that you're using, you can actually go in and set group tooling that will auto swap those tools out when they discover if they're bad or not, as well as based on linear footage for wear type settings, right? So what I would have you do is I would have you actually go in and I would need the block of code that you would want to reference, and then we could modify our probing or our tool check cycle to do so. Now, another way you guys can do this, again, it's all post dependent, guys, is you could do a manual NC, and again, you could do tool break control this way, and when you post out, it's probably going to make me a liar again, is you have that ability to create an automatic NC. There it is. So you could, for some reason, the checkbox isn't working, but there's that code being dumped based on a manual NC forcing. Now, when we force that with manual NC, there's a lot of things you could do, but we could make it so that macro counter is called out at the same time, right? And if you guys have never seen me do this one, we could obviously go in. You could do a pass through, which a lot of my customers do. And that pass through is basically whatever you put in the pass through. We could say something like jitcadcam is amazing. And what that is going to do is when we post out, it will actually insert that automatically into your G code as well. So if you wanted to do a pass through, now the problem is notice how my pass through is getting called before my M5 and M9. This is why we're going to have to do some post edits, and you're more than welcome to reach out to me to kind of help you and guide you through that, of course. What other questions do we have? I see the chat slowed down a little bit. I see people coming and going. You guys all get to hear me sit here and ramble on and ramble on and ramble on. What other questions are we working with today, guys? No problem, Ash. More than happy to help you guys. See you guys in here all the time. You guys seem to come out here every week. I see. Oh, nope, that's something else. Checking my phone, because sometimes I get notifications on my phone where one of you guys are texting, calling me, and telling me something's wrong. Nope, it's somebody sending me a photo of myself doing nothing but sketching things out. So, I appreciate you guys. Oh, that's right. Andreas, there you are. There was one I forgot, right? Okay, this is a good one. This is a really stupid but funny good one. So Andreas, if you guys don't know, Andreas actually helped us build our Discord channel out to be way better. He presented me with a very unique problem. Is if you have tools with presets, so let me go ahead and get in here. He's going to put me on the spot and make me show you guys this. So we discovered it's kind of a wild item, but if let's go to this crib is pretty empty. So if I have a turning tool, right, and I'm just going to create a couple of presets here, and you guys will see how funny this is. Again, this is another good one. I think this is how Autodesk understands how to develop product. Autodesk, you need to figure this out. But let's say I create a brand new tool, right? And this is going to be not the same style of tool or the same make of tool, but let's say I have a turning boring tool. And I think you guys all know, just like I know, is one, the insert for an OD turning versus an ID turning, like it could be the same, which means the speeds and the feeds could be the same, right? So what he actually discovered is if you come down here and you copy all of your presets and you want to go to that other tool and paste them in, notice how you can't actually paste them in. But if you had a same tool here, again, this is an OD turning or a general turning tool, I can actually copy these presets from one, and then I could go to the other one and I could paste them in. Now it's not doing it, see? Oh, it's because I did a threading tool. I'm having one of them days, guys. All right, let's switch this out. So I'm gonna have to create a brand new tool. All right, let's go to threading. Either way, you guys are gonna see this and you're gonna laugh. All right, so for the sake of this, is I could now paste in those presets to that threading tool, right? Same rule would apply with my general turning tool. If we went in and we say, let's just do 1, 2, 3. If I wanted to copy these presets over, which I got to ask you guys, how many of you guys knew you could actually copy your presets this way? Kind of cool, isn't it? Is if I wanted to copy them from my general turning tool over to my boring tool, I cannot do that. And the workaround that Andre and I found, it's a terrible workflow because you're going to see why, unless they magically patched it, is I need to duplicate this tool, right? And the reason why I need to duplicate that tool is because I need to change said tool, right? And what we're going to do is we're going to go in and we're going to go to that tool, and this is going to become our boring tool because the tool that we're coming from and going to needs to have the corresponding things. Now, for some of you, you're probably like, the turning to boring that would be perfect, right? I just want to, that's more than enough. But if you want to copy these now and paste them, as you're seeing me do, I can copy and paste them because it's the same style of tool, right? But if I go back to the original tool, Andre, watch, it's not going to do it this time, watch. But if I try to change my original tool back, nope, it didn't do it. It kept our presets. Okay, so it's more than okay. Before, it was funny. It was dumping his presets from that original tool. But as you can see, the amount of pain in the ass that it kind of is, and yes, I will agree with anybody that if you're just going to take one tool and you're going to duplicate it and then go in very quickly and swap out, you know, whatever you want to swap out makes sense to some extent, right? But what doesn't make sense to me is the fact that what if I wanted to just move one preset from one tool to the other? Now, again, maybe I use preset 1 on this OD tool, and now I'm boring with it. Why can I copy and paste only certain things, but I can't copy and paste everything from what it seems, right? Again, there's my copy, but I can't paste. Oh, it dumps all the sizes of inserts. Okay, that's what it's doing. Yeah, again, 100%. So he's right. So it was dumping other information. So again, that's kind of something different and neat, right? So again, copying your presets from one tool to the other is kind of a pain in the ass. And I mean, I think, and I'm in agreement with a lot of people, like to go from, you know, a general turning to a boring tool, copying those presets should be a no-brainer because it's usually the same inserts. It's ISO insert certification. Like they're all almost the same. So why can't you copy and paste them without just, again, you can duplicate, of course, and I'm all about that, but let's be real. A lot of us like that copy and paste feature. So I'm going to go ahead and jump out of there. And I do say, how do you add an M00 into the program? So Adrian, as you guys saw me do on this part over here, oh, where was that part? Here it is. Oh, we'll go back to this one. I like this part. This is a much more aesthetic part. Again, is when I'm posting out, if I need to add an M00, I would do a manual NC, and then you could do a stop, and a stop will trigger an MOO. So when I post this now, but you're going to see, and again, your post processor has to support it. I'm now forcing an M0 here in my program. So as Adrian's telling you guys, definitely 100% always build a dump tool and make sure back your stuff up, as we've all learned, right? So Deep Thinker, I see you out there. How do you share a team member a tool list? So yeah, so this is actually a pretty good question. And I don't know why Autodesk does this. This is another one that just drives me absolutely crazy, right? So I've seen this a ton. How do you share your tools? Well, one, you have to store them in the cloud, right? And you have to turn on the cloud. But once you turn on the cloud, you'll notice here I have all of my tool libraries. And what you notice down here in my local library is completely empty. I don't really keep any tools in my local library. There's not really a reason for it, because I put them all in the cloud to be shared with my employees. Now, with that, how you turn on the cloud library is actually pretty straightforward. You can go to your preferences, and then we're going to go to manufacture. And for those of you that have heard this a ton of times, you're going to go ahead and check this box right here, Enable Cloud Library. And I suggest checking all of these boxes all the way down. So as some of you guys have seen, I've got cycle time showing up. I have tool information showing up. That's all right here in this actual list of things to be checked, right? So as you can see, is that's how you can activate the tool library. And with that tool library, you have that advantage to be able to share everything and build everything in the cloud so that you can access it at any time. Now, what I am going to do real quick, I am going to turn my screen off for a brief moment because I'm going to show you something else, but I got to make sure that nobody's email is lingering out there for you guys to see. All right, we should be good. So back to my screen. So the other way to go about it, and now this is for any of you out there, and I've worked with a lot of customers out there that they hire on employees and then they buy them seats of Fusion. However, that person doesn't really have a company email. So my suggestion is because we can assign a license from the company to a user, is you use the email that your actual machinist is using for payroll or whatever with the company, right? So now those people are a different use case because they don't have the same domain. So you do need to add those people at your actual tool library. And as you guys are seeing here, is if you try to come in through the assets way, the way I am I can't actually add that person because the invite is grayed out. So what you need to do is actually open up the web viewer, which mine is opening on my other screen. And you need to change the permissions to those people to be able to actually add them into the assets folder. And how you would do so, and again, I'm going to just verify real quick that nothing is going to come up here that shouldn't be coming up. There is quite a bit, so I'm not going to show you guys that screen, but I will tell you, you need to change somebody from a, I'm trying to remember what it is. It's like a team viewer to a team member, but you need to add them to your team specifically, right? That's going to be the whole problem that you're going to face, is adding those individuals to the team would give them access. And by team, I mean your actual team up here on the left. That gives them access to those additional assets folders. And again, the same rule applies for anybody and everybody. As you guys saw me look at my tool library, my machine library is also based on a cloud storage. And again, when you enable that cloud storage, you'll have that. Deep Thinker, I hope that kind of helps out. I mean, I hope that sets you guys a little bit more straight. You definitely, a lot of people miss that. I don't know why it's not turned on by default. I don't know what Autodesk does over there. I feel that it should be 100%. I'm going to give you guys a few minutes to ask any other questions you guys have while I drink my lovely monster that you all bought. Anybody else have any other questions? We have Adrian, Andreas, both in here. You guys are confusing me. Make sure nobody sent me a message in the ticket system. That's what we should do real quick. And nonetheless, I can clean some of this stuff up. Let's go ahead and say yes. Let's get back here. Yep. Oh, I knew you were going to ask something like that. Why did I know? The good old-fashioned 5-axis settings, right? All right, we could do that. That's fine. All right. Travis is asking 5-axis milling questions, of course. So I'm going to draw a part here real quick. Bear with me while you guys watch how terrible I am as an artist inside of Fusion. Let's just say we have a 4-inch inside. We'll just make this a 5-inch outside. And we're just going to drop a line across here. So if any of you saw the video that I posted like a little snippet when I was helping a customer. And the issue is on that part, we actually have to modify this a little bit to make this, right? But they kind of had a undercut feature. There we go. Beautiful, right? And with that being said, is the problem is the way our tool path was going through this. So if we're in manufacture, and I got to remember how I did this, so this is going to be real fun. Stock is going to be the same as our part, just makes this whole thing easier for all of you. Go XYZ up, beautiful. So if I was to go in and machine something like this that was being asked is, for example, I'm going to use like I think we did parallel is what we ended up with. And then let's just go ahead and let the tool do what it naturally does, of course. Half-inch, quarter-inch ball. Now, what you notice is we're not able to undercut inside of our part right now. And that was the big part that we had. And that was, all right, hold on here. Travis is putting a bunch of stuff in there. Okay, no problem. I get you completely. So as you guys can see is in the case of this is trying to machine inside of a part. Now there's a lot of tricks to this and there's a lot of things that can be painful on a part like this is if we went to 4-axis and then we set our rotary axis based on our X. In this case, I need to fix my setup. Bear with me, guys. We actually want our X axis to point down our part. And there we go. Let's set our X-axis this way. There we go. Means our toolpath will change what it does, right? So again, based off what's going on is we're getting some problems where this tool is pointing outside in, right? And again, we now have the ability to modify this, and I'm going to show you why this is important, right? So the idea is right now is it's pointing to rotary axis, right? So it's thinking outside the cylinder, machining inwards to the part. So what we ended up doing, if I remember correctly on this, is we went back to design, and I think we created a sketch, if I oh so certainly remember. And we actually did a sketch by offsetting this up in the air a little bit. What you're seeing me do is I'm putting a plane higher up. We've created that sketch, and then I'm going to just drop a line down my part. Now, the idea is this line, we're going to use this to control from the center line of our tool outwards. Travis, if you want to send it over to me, yes, please. But when I go back to manufacture now, in this case, I can actually use my actual line that we drew. And the idea is I want to go from curve, because the idea is we want to go from this line I drew out projecting, right? So if I go from curve and I pick that curve, what you're going to notice now is my tool is still in the same position, which is I'm going to go ahead and pause here because I feel like I'm just going blindly into this. And we're going to wait for Travis to send me the part. So as you guys are seeing is we should be able to actually set that to come in from the outside. Let's go ahead and see here. And rotary axis, setup X, yes. And, oh, you know what it was is, yep, it based on that. And we're going to change that up here. From curve. There we go. Starting to get a little bit more of what we want, but I'm going to wait for that part to come through. In the meantime, if you guys have any other questions, I do see somebody asking about steep and shallow. And I would be curious, what is it that you want to see specifically in steep and shallow, or what you're thinking with steep and shallow? Actually, I kind of have a good part for steep and shallow. Somebody sent me this lovely example. So steep and shallow is a newer toolpath to Fusion. I love it a lot because it starts to combine a lot of things. And on a part like this, it will actually work quite well. So same kind of thing happens inside of Fusion as we have our machining boundary. We want to machine the slot, keep the tool inside the boundary. And what you're going to notice is what's different about this toolpath than most of the other 3D toolpaths is, one, we have the ability to say only certain situations or do both. But we also have what's called a threshold angle. And what that threshold angle is at the end of the day is when do we transition from our two strategies, right? So in our steep area, very similar to 3D contour. In a shallower area, we have a choice of scallop or parallel. Now I'm going to leave everything default so that you guys can see this. And with that, I see what you're saying now. Steep and shallow is your suggestion, not that you want to see. I appreciate that. We'll go ahead and take a look at it here in a second. But as you're seeing is as we start to work up the edges of this part, we're changing strategies, right? And how we're changing that strategy is we're machining up this wall with a contour. However, on the end of our part, we're starting to see that scallop. Now, we haven't transitioned at 30 degrees yet. So if I was to change 30 degrees here, let's say we were going to go down to 15 degrees. What you're going to notice is at some point, our scallop toolpath is going to stop and we're going to transition into that 3D contour kind of strategy. So the idea here is steep and shallow works really, really good on parts like this to be able to go in and define that. Now we could, of course, go back to that 30, right? And what I'm going to do is instead of scallop, we're going to say parallel. I'm going to pick my direction to make sure that we run the length of our part. And now instead of coming out and around and kind of doing that rectangular shape like scallop is good for, we are now running the full length of our part. And we do need to get out our linking moves so that we can see, again, oh, let's turn off points too, just to make this easy. And now you're seeing we're just running straight down and back on this part. And then as we're starting to get into those walls, we're starting to come in and do a contour strategy, which is different. And let's go ahead and turn on our contact point boundary and see if that gets us up those walls. In the meantime, Travis, you get a chance to send that part over yet? We're all waiting on you, holding our breath. Oh, one more time here. There we go. We're getting all the way up the walls now. Let's go ahead and make a few more changes. And what we're going to do is we're going to go ahead and give this a much bigger step down so that we can see the defining of it much cleaner. I see some other questions coming in. All right, just sent it. All right. Is there a way to create a polygon in Sketch where we decide a number of sides by a parameter? In that case, it works when it's define it, but later when I edit the variable, the sketch isn't updated. Let's go ahead and see. We can find out pretty quick. We want to create a parameter, and we want to create our own user parameter, and we'll just call this number of sides, and this is going to be no length or no units. We're going to start with 6. The reason why that's no units, just so you guys know, is because that is an integer, so it's got to be a solid number. But if we create our sketch now, and I go in and I create our polygon, and for the sake of this, let's just go ahead. Oh, nope, we don't want to do that. Let's dimension this. Right? And I do need to edit that polygon. See here. I'm not quite clicking it. Maybe we'll have to draw a new one from scratch here. In Sketch, plane, polygon. First, I'm clicking too fast. We'll get it one of these days. We'll hit the tab key. Number of sides. Oh. And if we go back and we change parameter number of sides to 8. Yep, it's not updating, which I assume what is happening is because a sketch is kind of a fixed point of reference, that it's not going to auto-update that number based on that. It's kind of like it's floating around individualized. I guess, again, this is one of those things. Autodesk, hopefully you're watching, is why can't we do that circumscribed and be able to update it with a parameter? Travis, let me check real quick. Did you send it to my email? You did. All right, cool. Let's go ahead and download this. We're going to go ahead and update. You guys got me all out of place here. Where do we want to go? YouTube content. And it's almost the end of the year. Crazy. Go ahead and clean up my files here while that uploads. I don't need this terrible monstrosity that I drew. Also, this terrible monstrosity can go ahead and get disappeared. So there's not a simple way to do that like you're asking. There's no actual hex box at the end of the day. There we go. All right, where's that part at? This guy right here, right? There's our lovely part, thanks to Travis. And this was one that he was having some issues with when he was machining it. Let's see here. Where was... Now I get to play the game of where is all the toolpaths. All right, that's the backside. That is also the backside. There we go. That looks like one of the ends. That looks like the other end. Travis, am I crazy or did I miss it? Or did you send me a file without it? Setup 4, flow 9. All right. Setup 4, flow 9. Oh, that's flow 13. Gotta practice what I preach. Let's drag this window open so we can find flow 9. All right, so there is flow 9. And then there was a sketch that we were using, wasn't it? Yep. As you guys can see, as I was hastily trying to draw in Travis's case, we did the sketch of the line. And with the sketch of that line, we actually have that ability when we did our multi-axis setting. Again, we have our setup X. In this case, his X is around center down here. And what we're doing is we're swinging that part back and forth. And then because we used from curve, that sketch is our curve that we're projecting our tool down with, right? And if you guys have never seen from curve or to curve or from point to point, it's really handy when you get into like a female cavity or something that's like internal at the end of the day. Fusion's hating me right now. I'm recalculating your tool path. But we could also turn on the tool path simulation and I could show you guys how that works. Andreas, if you want to build a plugin for Fusion, I'll sales pitch it for you that on how to a hexagon builder, or should I say what is it, a poly something builder? As you guys can see, it's going to take a minute to calculate. Granted, I am live streaming video and everything all in one shot, so we'll give this a second. This is one of them valuable reasons why I tell you guys to turn your tolerance up when you're just playing around with stuff. But if we simulate this, we'll be able to see how that tool is going to reflect versus the center line of that actual. So again, let's go back up to our setup and let's get our sketches turned on. And we should be able to see line for curve. Travis has that turned on. And now you guys will see how this kind of interacts with our part where our tool is going to come in. And for this actual setup, we're going to say, let's look at the tool, not the part. But as you see, the tool always stays vertical, right? But now his rotary is swinging back and forth, and now you can see how this line goes up and down. The tool stays on center of that line. So again, it's now got the freedom to move left and right as it machines across that part, which is super neat at the end of the day to see based on what's going on. I see a bunch of questions just come through. Did I lose connect in there for a minute, or? There we go. Part took forever. I bet it did. It doesn't seem like the best of scenarios. But as you guys are seeing, again, the idea is because we said from curve and we gave it a curve. Now, your curve doesn't have to be a straight line. You can actually do quite a bit with from curve. But as you're seeing, it's always maintaining the center line of the tool intersecting that actual line, regardless of how far down the part it goes, right? So if I hit play here, you'll see it works its way down the part from end to end, doing its little dance. Don't throw up on me. I didn't realize when we were doing that, it was going to shake the view cube too. Let's get a little better view on this for you. Awesome. Yeah. I mean, it worked. That was the idea, is from curve was limiting our tool on a fourth axis to always stay inside and machine those undercuts. Those moves look sexy, right? You have to just make it rain in super chats. What other features are you referring to? Oh, I know what you're talking about. Didn't I do a video on this, guys? I feel like I did a video on this. Did I not? Where is my YouTube channel when I need it? I know I did a video on this. I'm not going to say where that video is, but I'm going to have to recreate. Where did I do that video? It was a while ago, wasn't it? Yeah, okay, I got it for you guys. It's called, all right, so it was a Workflow Wednesday one, and it was the, let me pull this up here. This is the video that I outline. Ignore this beard. This is not a real beard. It does not sit on my face. But as you guys can see here is I actually go through the process in this video. It's an older one of my videos, but how I can use like this line here or the curves and things of that nature, right? This is a good video. If you guys haven't seen this video, I don't know why I'm watching my own video on this channel. I missed that beard. Look at that gruesome thing. But yeah, this was a really good video. This is one of my old videos. This is a year ago. You guys are making me look back. But as you can see, you could set your settings up, and then I walk you through how to do that in that video. Which, with all of you guys in here, it leads me to a perfect time. Guess what? I do live content all the time. I'm still waiting for more recommendations on the old Mill Turn Thursdays. You guys can catch me on both Workflow Wednesdays and Free Support Fridays. I am doing my best to make sure we have these videos live for you guys every week, covering any subjects that you guys have or anything in particular that you want to see. We are also always thankful for each and every one of you for buying me beer, being a subscriber, whether it be to this channel or purchasing your Fusion through me. But what other questions do we have from you guys? Are we going to wrap this up early? Oh, no. Holy sh... Excuse my language. Better have this 8 minutes left. Holy cow. Man. I'm flew today. See how much more fun this is when you ask questions and I don't have to sit here and just draw stuff? Yeah, it's getting better. They've done a lot with it. I would have to see more about your specific workflow as to why it's not very good at fourth axis rotary. I do know they just dumped like literally the ability to put fourth axis on basically any 3D toolpath. But also your polar milling side is controlled in your post or in your machine coordinates. Actually, I got one more I think I'm going to leave you guys with. This was a really good one. And I'm trying to think of the best way to show. I know how I could show it. So this was a really good one. So I'm not going to do it on this part because it's going to be quite a good time, to say the least. All right, we'll do it on this part. So somebody was asking me, when do you select your machine? And now more than ever, you guys should be selecting your machines. It's 100% me being honest with you guys. But what I'm going to do is I'm going to build a machine. Don't do this in your local area. But what I want to show you is you can set a home position for your machine in your kinematics tree, right? So what I'm going to do is I am going to use the Haas post again. No, guys, I am not sponsored by Haas in any way. It's just very easy to grab that post and use it. Let's see. We'll go ahead and play it where it lies. But in your kinematics tree, you could actually set up your machine, right? So if your machine has limited range, of course, in your X and your Y, which with machine simulation, you should have that all set up, right? So it might be 0 to like 250. And then maybe in X, you have like negative 100 and positive 100, right? Now, when you have these all set up properly, you can actually define home positions. So for example, in my Y-axis, maybe I want a home position of like 12.5 for some terrible reason. And in X, I always want to be at negative 100 or negative 10, right? Now I know millimeters versus inches, guys. It's like only 4 inches. We get it. If anybody knows about 4 inches, it's probably me. But as you can see, we're going to go ahead and select that. And with that being said, is when we post this out, as you're going to see in my G code, I can actually use that home position and machine definition to control where my machine goes home at. Now, this works really well in your settings. As you can see, there's my X10, there's my Y12.5. And then if I was to do something with the Z, so if you have a machine with a Z axis and you need that Z axis to get up and away, or if you have a lathe that you want to put things into certain positions, using machine definitions work very, very well, especially by being able to control your home positions and move things around. So with that, I think that wraps everything up. Let's check our questions here. Is there a way to add a % of passes on instead of step amount? No, there's not really a way to do it based percentage. I mean, you could do an expression based on percentage, but it would be a little tricky. I'll play around with it this weekend, Travis, and we'll see what we can do with threading and percentages. On machine definition, how would you add through error? All right. Why did I open my mouth about stuff, right? All right. So if I edit my machine, Deep Thinker, are you talking on the turning machine or the milling machine, right? So if I go to my kinematics here on a mill, I can actually go to my head. And as you can see, you have all your settings for your coolant right here. So if you have through coolant, or if you have through air, or through and flood, you can toggle that all on right here. Now, your post processor is going to have to support it as always, guys. So I will show you this before I wrap this up. And what we're going to do, we're going to hit the little edit button. And then what you're going to look for is your coolant, right? I'm just control finding coolant. Again, you have coolant pressure. And then what I'm really looking for is your coolant IDs, right? So one, this is where when all of you guys ask me about changing M codes, here's all your coolant codes, right? So maybe your through coolant isn't 88, it's like 188, and then you don't have 89 off, you're just using normal 9 off, right? All completely controllable right here and changed based on what you spit out. So what I tell people is if you want to change this on your own, you're more than welcome to. You can also reach out to me, but post it out, see what it gives you, and then just use the good old-fashioned Control F to find what it is inside of the actual post. So with that, guys, I'm going to go ahead and leave you guys to it. And I am going to hit you with the, it's not what you know, it's who you know. Of course, you know Phil Brown over here at jitcadcam. As always, I'm here for you guys to help in any way I can. And I hope you guys have an outstanding rest of your weekend. And for all of you that are working overtime this weekend, I hope you get through it nice and healthy and get some time off before Monday. Thanks, guys.